So look at the very first table for linear. In order to see really how to obtain a linear graph, a linear equation, we're just going to look at how you get from one value to the next. So, but just always keep in mind, or just remember, f of x is the same as having a y. So this is still an x and y table. A lot of people try to think of these as x values just because they see the x, but it's f of x, function of x. So how do we go from -2 to -1? Add 1. And then -1 to 0. Add 1, 0 to 1. Add 1, and then 1 to 2. Add 1. So you obtain, or you get a linear, you get a straight line when you have a steady rate. Remember, the rate is how fast your line is going up or down. So, but since we are adding the same exact amount every single time, you will end up with a straight line, okay? Now, a steady rate, when you're adding the same exact number, you end up with a slope. Slope is only associated with linear equations. So anytime you see the word rate of change, if you see the word slope, per, each, you're only talking about linear equations, only talking about straight lines, because you are adding or subtracting the same number. It's always the same number. Think about if you have a job and you're getting paid $10 an hour. You're going to get $10 every single hour. Hour 1, $10. Hour 2, another 10. Hour 3, another 10. Hour 4, another 10. But it doesn't fluctuate from that. It's not you get $10 the first hour, $12 the next hour, $13 the next. It's just 10. You get a straight line. Okay. Parabolas. So let's look at the values first, and then I'll go into the explanation part. So 4 to 1. -3. 1 to 0. -1, 0 to 1. +1, and then 1 to 4. +3. Okay. Notice we have a decrease and then an increase. Sometimes you could have an increase, then decrease, depending on which way your parabola is reflected, whether it's reflected or not. But you are not adding or subtracting the same exact number. That is because a quadratic, what makes a quadratic special, remember, is the squared, right? Now, if you look at your equation for linear, you have x, but when you don't have an exponent, that's considered to be x to the power of 1. So now let's look at this. Same thing here. Since this is linear, this is your first power. This is the first power, but let's see what happens when we look at the difference the second time. So -3 to -1, what do we get? We add 2. And -1 to a +1, +2, 1 to 3, +2. So the second exponent is where you see that constant addition. And remember, keywords that you want to look for is just projectile. Notice that you are throwing things. Throwing, kicking, swinging, anything like that. Now, exponential. Exponential is where you will end up seeing an exponential growth, an exponential increase or exponential decrease. Exponential meaning in multiples. It's going to be multiplied to get from one value to the next. Remember, your factor is also called your multiplier. So let's look at the values. How do you get from one to the next? But decimals are always hard to figure out, especially in your head. So let's go ahead and start with the whole numbers. How do you get from 1 to 2? Multiply.
Oh,
Times 2. Now I'm going to put that times 2 in parentheses. I don't want to use an X because it can be confused with a variable. And how do you get from 2 to 4? Times 2. So now, say you have a quarter, you multiply it by 2 quarters to get 50 cents. 50 cents times 2 gives you $1. So you're multiplying every single time to get that type of growth. Remember, we talked about the scenario where, or the real world explanation, the COVID cases, you have one person that infects another, those 2 people infect another 2, those 4 people infect another 2, and so forth. Let me get mine. Oh yeah. I go home and thank you, but they're not. I go home and my feet are throbbing and then I still have to stand up and cook. So you're multiplying the same number. You're multiplying the same number. Okay. All right. Now, what's up? Yes. I think dimming the lights might make it more glary. You don't have to do it together. Is that better? No, it made it more glary. I would turn off the light. Arla, turn on that lamp. I think you just touch it at the top. Is it not connected? Maybe. Yeah. You can turn it on. We have. Can y'all even see y'all's notes? Yeah. Seriously? Yeah. The hallway light. So overall, after this lesson, I want you to be able to find the y-intercept and recognize how to find the factor, or in general, not exactly find, not to find the exact number, but just know in general, what type of number am I looking for in my factor based on the information I can see from the table or from the graph. So we're going to be looking at all 3, the graph, the table, and once again, we'll look at the equation. Should I wait? All right, so let's start off right here. First, the initial value. Just know the initial value is the same exact thing as your y-intercept. They're the same thing, but they're both asking for 2 separate types of numbers. Let's first look at the equation. What is my initial value? Where do I find it? It's 1, and it's always going to be the number located in front of the parentheses. If there is no number in front of the parentheses, that number is 1. Now, pay close attention to the word value, the word value. We've seen that word before with quadratics when I would ask you for the minimum value or the maximum value. If I asked you for the value, I was specifically asking for what? The y value, not the y-intercept, but the y value. Because even with minimum and maximum, I was asking for the y value of the vertex, not specifically the y-intercept. So initial value, the initial y value is 1. In this one, yes, you can just simply give me the number 1. If it asks specifically for a y-intercept, this is a position on the graph. So you do have to write this down as an ordered pair, 0, 1. So you write as a point. Or ordered pair, whichever one you understand more. Write as an ordered pair or as a point. Now, let's take a look at that graph that is provided. All of this equation revolves all around this graph and also the table. So everything goes together. You're just seeing it 3 different ways, because you're always going to be provided one of the 2, either the graph in the table or the table in the equation, or the equation in the graph, okay? So we always find that y-intercept where? Where it crosses the y axis. So the y-axis is this one. My line is crossing the y-axis here at the number 1. So there's my y-intercept, 0, 1. Okay, easy peasy. On the table, where do you see the y-intercept? In the first point, second point, third point, fourth point, fifth? The very first point right there, 0, 1. You need to be able to recognize a y-intercept on a table, and that is where the x is 0, not where the y is 0, where the x is 0. So 0, 1 is considered the y-intercept. Got it? All right. So moving on into the factor. What is the factor of that equation? Where do I find it?
Greater than.
It's the number 2. Your factor will always be the number in the parentheses. Your factor will always be the number inside of the parentheses. And if that number is greater than 1, b is greater than 1, we're going to see exponential what? Growth or decay? Growth. And once again, the reason I use b is because that is the variable that they use for the factor. B is greater than 1, so we're going to see exponential growth. Greater than 1 and growth. My factor is 2. I'm going to go ahead and leave it in parentheses, so I remember that that is where I find it. It's always the number in the parentheses. Now the factor is also called the multiplier. Just like we went over with the other sheet, where we multiply by 2 every single time to get from one value to the next. So that 2 is the number we multiply to get the next y value, specifically the next y value. That's the number that we're going to be multiplying to get to the next y value. 2 times 2 is 4, times 2 is 8, times 2 is 16. That is the number we multiply to get to the next y value. Everybody got that? Nobody said no? Okay. Okay, so understanding the factor from the graph perspective, just in case we're not given an equation. First things first, you want to see what direction that line is going in. From left to right, are you going up a mountain or down the roller coaster? You're going up. So if you're going up, that means we're going to see a what? An increase. And if we see an increase, that represents exponential growth. So our factor is going to be greater than 1. We're going to see growth. Because in general, going from left to right, always left to right, our line is going up instead of down. Now, as far as the table, it's very difficult for some students to see or to understand what number you are multiplying to get from one value to the next. It's easy when you have whole numbers, but you're not always going to have whole numbers. Sometimes you're going to have decimals, and it's hard to try to imagine in your head, oh, well, I'm multiplying by 0.75 every time. So in general, you want to see what's happening with your y value. So how do you get from a 1 to a 16? What is happening? Are we increasing or are we decreasing? We are increasing. So as far as the factor, if your y value increases overall, meaning in general, just get a general idea. Is the number going up from 1 to 16? 16 is bigger, so it's increasing. So the number in the parentheses, your factor is going to be greater than 1. It's going to be growth. And that should be enough information for you to answer the questions. as long as you can look at the table and say, oh, that's growing. So I'm looking for a number larger than 1 within the parentheses, that's enough. Got it? Questions? All right, let's look at the next one. Starting with the y-intercept, the initial value. Once again, the initial value and the y-intercept are the exact same thing. Now, in this equation, they don't give us one, so we're going to start with the graph. Let's start with the graph. Label your x and your y-axis. What is my y-intercept? It is it's crossing the y-axis at the number 1, so the y-intercept is 0, 1. That means I could go ahead and fill in front of the parentheses a number 1. Okay. And where do we see the y-intercept on the table? 4th line, right there. So circle that. And I'm just going to draw a line. Y-intercept, there it is. Y-intercept, pretty straightforward. Any questions so far on that? Okay. Factor. Let's start with the table this time instead of the equation. Let's say we're not given an equation and all we can do is look at the table. What is happening overall in general to my numbers? They are decreasing. So as far as the factor, my y values decrease. So that means that b is less than 1. And if b is less than 1, we see what? Decay. We have decay, exponential decay. Now, even if you don't know what the value is, by the end of next week, you will. We'll do regression on this. So for now, that's all you need to know. So decay, b is less than 1, decay. Now my factor is what number? We get it from, go ahead and get that from the equation. 1/2, always the number in the parentheses. But remember, sometimes we do need it in decimal form. So 1/2 as a decimal, 0.5, 0.5. And these are all just tools that you want to use, things you want to look for, recognize to answer all of these questions. What's up? In a little bit. Factor. Your value of b is less than 1, representing decay. And remember, not all fractions represent decay. Not all fractions are less than 1. Got it, Angel? Okay. What did you need? All right. Now the graph. Say we're not given a table, we're not given an equation, we're just given a graph. You can narrow down all of your answer choices just by knowing what direction it's going. So for your factor, what direction is that line going in? It's going down. You always start on the left side. Every graph is read the way you read a book, left to right. So from left to right, we're going down. And if you go down, that means we are seeing a decrease. And decrease means decay, meaning we have to look for a number less than 1 within the parentheses. So first thing you want to look for is the y-intercept. And since it's going down, you want to look for a decimal or a fraction in the parentheses. But you can always narrow down any answer choice just based off of that. Okay. Anybody need more time for that? All right. Next one. Initial value. Always want to start with that one. So initial value, y-intercept, exact same thing. Let's go ahead and grab it from the graph. It's crossing at the number 4. So our y-intercept is 0, 4. And the initial value is what? Just the 4, correct. They're asking for a value. They're only asking for one number, y value, the initial y value. You can go ahead and put y value there. Okay. It's not given in the equation. So it's next, we're going to look for it in the table. Where's it at? The very first one, 0, 4. Not all tables will include the y-intercept, just FYI, because that will happen on today's assignment as well. Not all tables include the y-intercept, but that's okay because you have other information you can go off of. But we found the 4 y-intercept, meaning I can fill this in with a 4. And the factor. What is happening in general to our numbers? They are increasing. We see some decimals. That's why I didn't want to get into trying to figure out what number we're multiplying. Just know overall it's increasing. So we're going to look for a number bigger than 1 in the parentheses. So factor. Y value increases. Y values increase, meaning B is greater than 1, growth. If your Y values are increasing, B is greater than 1, growth. Look at that equation. The only thing here that you see is a fraction. So a lot of people see a fraction, automatically think decay just because of the fraction. Let's say, for example, you're not given a table or a graph. You're going to have to do what to that fraction? Convert it to a decimal. Because technically it's already simplified. So convert it to a decimal. 3 over 2 converts to 1.5. And that way you can recognize that B is greater than 1, meaning exponential growth. Your graph, your line is going in what direction? Up. It's increasing. It's going up. Increasing. If you see an increase, that means our factor will be greater than 1. So we'll see exponential growth. Everybody got that? Mm-hmm. All right, so B is greater than 1. We see exponential growth. Our factor is 3/2 in parentheses or 1.5 or 1.5. Last one. Ready? Okay. What is my initial value? 3, 0, 3. Got that initial value right there. This one is kind of bigger, so I can write that in there, 0, 3. Here's my y-intercept. Once again, not all tables have a y-intercept. So let's go ahead and fill in a 3 right here in front of our parentheses. And if you look at the graph, it's already labeled for you, y-intercept right here. It is already labeled. So that one was an easy peasy point. All right. So our initial value is going to be 3, but the y-intercept as a point, as an ordered pair, 0, 3. Okay. The factor, look at the equation. This factor is what? Greater or less than 1? B is less than 1. 0.8 is less than 1. So less than 1 meaning we will see exponential decay. So what should we be seeing with the values on the table? The values should be decreasing, and that's exactly what you see. Even though you have a bunch of decimals, decimals are always confusing, but 4.6 definitely bigger than 1.9. They are going down. Okay. So let's go ahead and write that 0.8 here. Don't have to convert it again. Factor. Y values decrease. So B is less than 1. We see decay. And tomorrow we're actually going to be interpreting these graphs. So you'll get a better feeling or a meaning behind all of the numbers. I mean Monday. Sorry. I didn't want to come in either. Okay, last one. Your line is in general going in what direction? It is going down. It's going down. Decrease. Down meaning it's decreasing, meaning we're going to be looking for a number less than 1 within the parentheses, showing us decay.